The objective of this lesson is to compare fractions by creating common numerators. In the previous lesson, we used 3 strategies for comparing fractions with common denominators. The strategies are as follows. If one denominator is a factor of the other denominator, use the larger denominator as the common denominator. Multiply the denominators to find a common denominator, or use a smaller common denominator by listing multiples of each denominator. We will be using these same strategies, but applying them to the numerators of fraction sets in order to make common numerators for comparing fractions. Let's begin with the first strategy of determining if the smaller numerator is a factor of the larger numerator. Look at the following fraction set, 3/5 and 9/12. Notice that 3 is a factor of 9, so our common numerator is 9. We need to find an equivalent fraction for 3/5 with 9 as the numerator. So we think, what would we multiply the 3 and 3/5 by to get 9? 3 times 3 is 9, and we would need to multiply the denominator and the numerator by the same number. This would give us the equivalent fraction 9/15. Now we are comparing 9/15 and 9/12. We can compare these by reasoning that both fractions have 9 pieces, but 15ths would be smaller pieces than 12ths. So 9/15 is less than 9/12. The advantage of this strategy is that we only need to find an equivalent fraction for one of the fractions in the set. However, not all numerators are factors of one another. Let's compare 3/5 and 2/3. We can see that one numerator is not a factor of the other. 2 is not a factor of 3. So this time we will multiply the numerators together to create a common numerator. First, we will multiply the numerator and denominator of 3/5 by the numerator of 2/3, which is 2. This will give us the equivalent fraction of 6/10. Second, we will multiply the numerator and denominator of 2/3 by 3, which is the numerator in 3/5. This will equal 6/9. To compare with common numerators, remember that both fractions have the same number of pieces, 6. However, the size of the pieces differs. 10ths pieces would be slightly smaller than 9ths pieces, so 6/10 is less than 6/9. While multiplying the numerators together works, we can also use a smaller common multiple to make calculations easier. Let's use the following fraction set with this strategy. Begin by listing the multiples of each numerator. The multiples of 9 are 9, 18, 27, 36, 45, 54, 63, 72, and so on. Multiples of 6 include 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72, and so on. Now identify all the common multiples, 18, 36, 54, and 72. We could use any of these common multiples as the numerator. However, since we're trying to simplify the problem using smaller numbers, let's choose 18. If we want 9/12 to have a numerator of 18, we need to multiply the numerator and denominator by 2. This equals 18 over 24. Next, let's create a fraction equivalent to 6/8 with a numerator of 18. To do this, we will multiply the numerator and denominator by 3. This equals 18 over 24. Notice they both have 18 pieces and the denominators are the same, so these are equivalent fractions. With this strategy, we were able to use smaller numbers to compare the fractions. However, recognize that there are several strategies that will lead to a correct answer. Students often think there is one right or best way to compare fractions, when in reality there are many strategies that may work equally well. The objective for this lesson was to compare fractions by creating common numerators. We met this objective by using 3 strategies: looking to see if one numerator was a factor of the other, multiplying the numerators, and using a smaller common numerator.